using constant dividend, using constant growth in dividend, or using CAPM. So in the question, the way the question is structured would tell you whether you are supposed to use constant growth in dividend or constant dividend or the CAPM formula. So let's go to the final leg, and that is to look at the cost of debt. Cost of debt, and that is KD. KD, cost of debt. Now, when it comes to debt, it is usually divided into two. We have the irredeemable debt and then the redeemable debt. The way you calculate the cost of debt for irredeemable is different from the way you calculate for redeemable. What does that mean? For irredeemable debt, the cost of debt KD equals I over PO. This is without tax. But if we take tax into consideration, KD will be equal to I over PO 1 minus tax. So this is with tax. So that is how we calculate the cost of debt for irredeemable debt. Irredeemable debt. So where KD is cost of debt, I is interest on $100 or 100 Ghana cedis nominal bond. That is very important. Always interest is expressed on the nominal value of the bond. And then PO is the market value of the bond. Remember, all these are times 100 because your answer has to be expressed in percentages. So that is how we calculate irredeemable debt. For redeemable debt, the cost of debt KD is internal rate of return. And I'll explain that in a moment. The internal rate of return. We've looked at investment appraisal yet, but you must gather the idea of internal rate of return. Internal rate of return is simply A plus NPVA over NPVA minus NPVB, B minus A, all percent. So we're going to be using this formula as a guinea pig to calculate the cost of debt of irredeemable debt. Now, what does this mean then? It means that we are going to be doing what I call trial and error. We're going to do the trial and error approach here. What does that mean? When you hear of NPV, it means that you are going to be calculating the present value of, so the NPV here is going to be the present value of the market value of the bond or market value of debt plus the interest rate plus the redemption value. Market value of bond plus interest rate plus the redemption value. Now, because you are dealing with present value, you need to look at the discount rate. So the discount rate you use here is where I say the trial and error. So with this one, the discount rate you use, I always advise students to start with 10%. When you start with 10%, depending on the results of the first one, you decide whether to increase it or to reduce it. Note that if you start with 10% and your first NPV is positive, then what it means is that your discount rate was too small, so what do? You increase the discount rate. So you increase the rate. But when you do the first one and your NPV is negative, it means your discount rate was too high, so you reduce it. Why? Why? We have a class. You reduce the rate. Now, these are principles, and I'm going to use a question to illustrate these principles in a moment. So, number one, if it is an irredeemable debt, it's a simple thing. You go for it, you calculate it. If it's a redeemable debt, then you have to think about it because you're going to be using IRR. So, let's crunch some numbers. Example, NP Limited issued 6% debenture notes at 85 cents, at 85 cents, redeemable in 6 years time at par. 6% debenture notes, redeemable in 6 years time at par. Required. Calculate the KD if tax rate is 25%. So follow me closely, and we're going to be using this for our illustration. Remember, I think you were not here, but you were here. I told you that debt can be redeemed at par, at premium, and at a discount. You remember that? You know that, right? So these are the three things. So in this question, we are told it is redeemed at what? Par. If it is redeemed at par, it means it is redeemed at how much? $100 or 100 Ghana cedis. So let's go and see how we will calculate KD. Remember, since you are hearing the word redeemable in 6 years time, my dear Webra will trim IRR. Then you note that you are going to bring three things: the market value, the interest, and then the redemption value. Then note that you are going to be doing a trial and error, and you are going to always start with what? 10%. So having this principle in mind, let's see how we go about it. So solution. We say that in this case, KD will be equal to IRR. And our IRR equals A plus NPVA over NPVA minus NPVB, B minus A, all percent. So we put a schedule up. So we're going to put the items here, or maybe we put year here, put cash flow in the middle, we put the discount factor here, we put present value here. Remember, what will be the cash flow? The year zero will be the market value of the debt. What is the market value of the debt? 85. So that's what you bring here. 85. Now that should be an outflow. Always at year zero, the discount rate is 1.10, or the factor is 1.10. So we'll get 85. Now, this is where I said the fair discount rate always use what? 10%. So we're going to say at 10%. Now we need a table to read. Then the next thing we bring is from year 1 to year 6. From year 1 to year 6, the second component, interest. note that because tax has been given in the question, the interest we bring here will always be the interest after tax. Very important. Remember also I told you that interest should be calculated on the $100 nominal value. So let's do that here. So int after tax will be equal to what? 6% times $100, 1 minus the tax rate, 25%. Does it make sense? What do I have? This will be $6, 1 minus 0.25. What? 450 or 4.5? No, it's not possible. 4.5. Okay, so 4.5. So that becomes the interest. That's what we put here, 4.5. So first, market value in bracket. Second, the interest, positive. Then in the sixth year, we bring the redemption. That's the third element, redemption value. We are told that it will be redeemed at what? Par. At par means $100, the nominal value of the bond. Now, how do we get a discount rate? The interest will be read on the annuity table, and then the redemption will be read on the present value table. So that's very important. Now, since you don't have the table, I'll just read it for you, but next week I'll try that we get a table. So let me just read annuity 10% from my table here. Annuity 10% for the sixth year is 6 years. So for the sixth year, 10% is 4.8. All right, 10%. 4.355. So we read the interest on the, now that is also very important. So read interest on the annuity table, and then read the redemption on the present value table. That's very important because there's going to be two tables. So I go to the present value table, 10%, 6 years is 0.564. Can I have my answers, please? This time this time this.
Interest.
Mm-hmm.
19 points.
What?
19.60.
60.
Yes.
5.64. 56.4. Okay. Add all for me. Negative 9. Okay. That is the NPV. What did I tell you? I told you that if the first NPV is negative, what does it mean? It's high, so you reduce what? The rate. So what rate do we use here? 10%. So in the second one, we will reduce the rate to what? To 2%. This one is based on judgment. Are you getting it? When you do the first trial, 10%, you can decide. If you go 2 and I go 5. Maybe you go 2. So we will put the second one here at 2%. Now at 2%, remember, the first one is always 1. So we will still have negative 85. But I will now read the present annuity factor for 2%. So let me go to the annuity table. 2% annuity factor. That is 5.601. Then I go to the present value table, 2%. For the sixth year, 0.888. So follow me carefully. Follow me carefully on this. Follow me carefully. That is why I said, on that side, I'm illustrating principle. These are principles. Now we are putting the principles in practice. So if you do the first calculation and it is negative, it means the rate you use is too high, so reduce the rate. That's what we are doing here. Can I have answers? Now, so this times 4.5.
25.20.
25.20. Then this times this. 88.8. So now follow me carefully. Give me NPV.
29.
What?
29.
29. Positive. So look at something here. Look at something here. Always, the one with the negative or the smallest NPV is the NPV A here. Is the NPV A. So the smallest discount rate is the NPV A, and the highest discount rate is what? The NPV B. Why is this distinction important? Because from our formula, we said NPV A minus NPV B. So now if I have this, my IRR will be A. What is the discount rate of A? 2%. So that's 2% plus, follow me carefully, NPV A, 29 over NPV A, 29. Now look at it, minus NPV B. The NPVB is negative 9. So it will be minus 9. Be careful here. Into bracket B. What is the B? The discount rate of B. 10%. Minus A. The discount rate of A. 2%. Can I have an answer? That is what gives us the IRR. 8.1. So meaning your KD is 8.1%. There you go. There you go. So that is how you deal with irredeemable debt. Did you get the same answer? Okay. So that's it. So very important, you are doing trial and error. Always start with 10. And this rule is very important. So if you do the first one, it is positive and can be increased. But if it is negative, you reduce it for the second one. And then you now get your NPVs and substitute that into the equation. Now, using the same question, let's pretend that it is irredeemable debt. So I'm going to use the same question, super this whole place. So MP Limited issued 6% debenture note at 8% and it's irredeemable. Calculate the KD. So if it is redeemable, we do IRR, but if it is irredeemable, we use the formula. So in using the formula, we say that, now remember, tax is here. So we need to use the KD after tax. So our KD will be equal to I over PO 1 minus the T. Remember I told you I will always be the interest. So our interest here is going to be 6% on 100, which is 6. So it's going to be $6 into bracket 1 minus 0.25 over the market value of what? 85 times 100. What do I have? 5.3%. There you go. So that's how you deal with it if it is an irredeemable debt. So when it comes to calculating cost of debt, you must listen to the question. If it is redeemable, IRR. If it is irredeemable, use the formula. That's the principle. Finally, so we've looked at equity on one side and we looked at debt on the other side. But there are times when companies don't raise finance totally from debt. They don't raise finance totally from equity, but they do a measure of the two. So if they raise part of the finance from debt and another one from equity, then this time around we wouldn't be calculating just cost of equity, we wouldn't be calculating just cost of debt, rather we have to calculate the weighted average cost of capital.